Hello, let's do some calculus with vectors. Today we'll be doing derivatives and integrals. The derivative of a vector function is just the derivative of its components. As an example, we'll take u of t equals sine of t, comma t squared, comma e to the t. The derivative is just cosine of t, comma 2t, comma e to the t. Let's look at some differentiation rules. The first one is linearity. The sum of two vector functions, the derivative of the sum of two vector functions, is going to be the sum of their derivatives. Next, we have the product rule. If we have a real valued function f of x and a vector function u of t, then the derivative of the product of the two functions is f prime of t times u of t plus f of t times u prime of t. The chain rule is similar. We have a real valued function v of t, then the derivative of u of v of t is u prime of v of t multiplied by v prime of t. Let's do an example. We have u of x equals x comma x squared comma x cubed, and v of x is x plus 1 comma x plus 2 comma x plus 3. We have f of x equals x squared. If a of x equals u of x plus v of x, then a prime of x, using the linearity rule, is 2 comma 2x plus 1 comma 3x squared plus 1. If b of x is f of x times u of x, then b prime of x, by the product rule, will give us 3x squared comma 4x cubed comma 5x to the fourth. If c of x is u of f of x, then c prime of x, using the chain rule, gives us 4x squared comma 8x to the fourth comma 12x to the sixth. Now let's look at the integral. If u of t is f of t, g of t, h of t, then the integral of u of t dt is just the integral of the components. Remember, if we're taking an indefinite integral, we always add a constant of integration. For integrals of vector functions, the constant is just any vector and constant vector. And this constant vector accounts for the plus c from taking the integral of f of t, g of t, and h of t. So we do not need a plus c inside the brackets. Let's do an example. If we have u of t equals sine of t, comma t squared, comma e to the t, then what is the integral? Well, the integral is just going to be negative cos of t, comma t cubed over 3, comma e to the t, plus c. Let's do an example using definite integrals. Let's evaluate the same thing, but from 0 to 1 of u of t. We plug it in and we get 1 minus cos of 1, comma 1/3, comma e minus 1. Now let's finally take a look at the unit tangent vector. What is the unit tangent vector? Well, we know that a unit vector is a vector of magnitude 1. Tangent vector is the same as the derivative of a vector at a point. How do you change the magnitude of a vector, and how do you make it 1? We change the magnitude of a vector by multiplying it by a scalar. To make this 1, to make a vector's magnitude 1, we divide by the magnitude of the vector. The unit tangent vector, therefore, at a point of u of t is just u prime of t divided by the magnitude of u prime of t. Let's do an example. What is the unit tangent vector of u of t equals t squared, comma t cubed, comma t to the 6th at t equals 1? Here's the solution. U prime of t equals 2t, 3t squared, 6t to the fifth. So u prime of 1 is 2, 3, 6. The magnitude of u prime of 1 is going to give us 7. Therefore, t of 1 is 2 sevenths, 3 sevenths, 6 sevenths. Thanks for listening. You can check out my worksheet if you want interesting problems.